exercise 3.6, derivative calculations. Right here we're given from exercises 1 through 8, you have y is equal to a function of u. In other words, y is expressed in terms of u. Now u is a function of x. So what are we going to do? We're going to find dy by dx, which is the derivative of f with respect to its argument times the derivative of the argument. Alright, so I'm going to do it in two ways. The first one is either use the Leibniz notation and of the definition of the chain rule, and the other one is you use the composition and again chain rule. So let's say we want to do number 1. So take y equal to 6u minus 9, but u is given to be 1/2 x to the 4th. Alright, so we are asked to find dy by dx. Now remember, dy by dx is just dy by whatever it's acting on, du, multiplied by du by dx. This is the Leibniz notation. So if we want to write it down, that means what is the derivative of y with respect to u? It's just 6. It's actually 6 minus 0, so it's just 6, multiplied by du by dx. So what is the derivative of u with respect to x? Well, it's 4 times 1/2 x to the 3rd power, just by power rule. So everything will be simplified now. It becomes, what is that? 12x cubed. Alright, this is using the Leibniz notation. Now, what if we want to use just the direct method? In other words, we do the composition first and apply chain rule. So let's write y in terms of 6 times, what is u? 1/2 x to the 4th minus 9. So if you want to rewrite that, it becomes 3x to the 4th minus 9, because 6 divided by 2 is 3. And then, really, when we're here, we may not even have to use chain rule, because now, what is y prime? Y prime is simply equal to 12x cubed minus 0. So you see how you arrive at the same derivative. Okay? Now let's look at number 2. Again, I will use the Leibniz notation first. So y is equal to 2u cubed, but u in itself is 8x minus 1. So dy by dx, remember we want to take the derivative of y with respect to x. However, y is in terms of u, so take dy by whatever it's acting on, du. Now, to get rid of that, you need to take the derivative of u. That's why you multiply by chain rule the derivative of u with respect to x, so that we will be able to get what we want, dy by dx. So that's equal to 6u squared times, now that's dy by du. You see how you take the derivative of y with respect to u just by power rule. And of course, multiple of a constant multiple of u cubed, and then we multiply du by dx, derivative of u with respect to x. It's just 8. It's actually 8 minus 0, which is 8. It's going to be 48u squared. And then apply what u is. It's 48 times, what is u? 8x minus 1 whole thing squared. Right. Now suppose we use the other method, the direct method. In other words, we do the composition to begin with. So y is equal to, same problem, okay, it's still number 2. What is our u? What is our function y? It's 2. Now apply what u is. U is a function of x, so 8x minus 1 whole thing cubed. All right. So here we want to look for y prime, or dy by dx. Here you apply chain rule. apply power rule on the whole thing. Look at the outside first. So the outside is 2 times something that was cubed. So bring down 3, you get 6, and it's 8x minus 1 squared. Then you don't stop there. Okay, remember we're not taking we don't write the derivative here. Instead, we multiply by the derivative of the inside. And then 8, because that's a derivative of 8x minus 1, so the final answer is 48 times 8x minus 1, whole thing squared. You see how you arrive at the same answer. All right, so suppose we do number 3 and 4. Let's try number 3 and 4. Let's do number 3. Right, so number 3, you've got y is the sine of u, and then u is 3x plus 1. Okay, so dy by dx using the Leibniz notation is the derivative of y with respect to whatever it's acting on, du, multiplied by du by dx. So that's equal to, what's the derivative of sine? It's the cosine of u, because that's a derivative with respect to u, multiplied by u prime. You see how you take the derivative, du by dx, a derivative of u with respect to x, which is just 3. So the final answer would be, put the constant here, 3 times the cosine of u, but we want it in terms of x. So now you apply the composition, 3 times the cosine of 3x plus 1. That is using the Leibniz notation. Now, say we do the same thing, but what we do now is we take y and apply the composition right away. Sine of, what is u? 3x plus 1. So now what is y prime? Again, you look at the outside. The outside function is that the sine of its argument. So what is the derivative of sine? It's the cosine with respect to its argument. Okay? And then you don't stop there, because we need to multiply by the derivative of its argument, the inside, which is 3. It's actually 3 plus 0, which is 3. So you see how we arrive at the same derivative. Okay? Alright, so suppose we want to do number 4. Say we want to do number 4. You've got y is the cosine of u, and then here, what is u? U is minus x over 3. So if you use the Leibniz notation, dy by dx is dy by what? By du. dy by du multiplied by du by dx. So what is the derivative of y with respect to u? It's the negative of sine of u. This is this part. This corresponds to this one. Multiplied by the derivative of u with respect to x is just negative 1/3. So that becomes minus sine. Well, it's no longer minus because it's negative times negative and put the 1/3 in the front. So it's really 1/3 sine of u. But then we want this in terms of x. So now you apply the composition. So what is u? 1/3 sine of, again, what's u? Minus x over 3. Okay. Now if we want to use the other method, we take y prime, or rather start with y, and it's the cosine of, apply the composition right away, minus x over 3. Right? So now what is y prime? Y prime would be the negative of sine of its argument, minus x over 3, multiplied by the derivative of the argument of cosine. So it's going to be negative 1/3. And you see how you arrive at the same answer. Okay? So the difference between the two is that you use the Leibniz notation, it's just a multiplication of the derivatives, and then do the composition. Here, we apply the composition first and then do chain rule. So either way works, whichever you're most comfortable with, that's what you use. Alright, so here, let's see what's going on right now. Okay, we've got, say, number 5. Let's do number 5. Okay, y is the cosine of u, and it turns out that u is another trig function. It's the sine of x. Okay, so by Leibniz notation, dy by dx is equal to dy by du multiplied by what? Du by dx. So really what you're going to do is take the derivative, multiply by this derivative of u. Okay, so what do we have? That's the negative sine of u. What does this represent? Dy by du multiplied by, now we're taking the derivative of sine of x, which is cosine of x. So what does that mean? That's du by dx is cosine of x. But we're not done yet because it has to be in terms of x. So all you do is now apply the composition. So it's minus sine of, what is the argument? Okay, the argument u is sine x. Okay, the argument of u is the argument of sine is again sine of x and then multiplied by cosine of x, right? So basically, if we want to rewrite that, oh, that's it. You have it. You get the negative of sine of x, because that's what u is, multiplied by cosine of x. That's derivative of u with respect to x, right? So now, if we want to use the other way, where we take the we do the composition first. So let y be equal to the cosine of, now what is u? U is the sine of x, right? So if we want to take the derivative of y with respect to x, take the derivative of the outside. The outside function is cosine of something. So what's the derivative of cosine? Minus sine of that something. Okay, and then we multiply by the derivative of whatever is that something, which is cosine of x. And see how you arrive at the same answer. Okay, now let's see. How about we do number 6. Okay, in number 6, you have y is the sine of u. And then what is u? U happens to be x minus cosine of x. Okay, so dy by dx, like we said, would be the derivative of y with respect to u. So let's go ahead and write that. Dy by du multiplied by du by dx. Okay, so what is the derivative of sine with respect to u? It's just cosine of u multiplied by, what's the derivative of u with respect to x? So that's multiplied by 1 minus, what's the derivative of cosine? It's negative sine, so the negative times the negative becomes positive sine of x. So let's rewrite that. It becomes cosine of, what is the argument now? U. U is x minus cosine x. This whole thing would be multiplied by 1 plus sine of x. There you have it. Okay, now suppose we do it where we use the composition right away at the beginning. So what is the sine of u if u is x minus cosine x? Replace the u by x minus cosine x. So y is the sine of, what is its argument? X minus cosine of x. Yes. Right, so what is the derivative? Again, when you do chain rule, you take the big picture. The big picture is that, take the outside first, it's sine of something, sine of its argument. So what is the derivative of the outside function? It's sine. What's its derivative of sine? Is cosine of, copy that same argument. You're not taking its derivative yet. Now you multiply by the derivative of the argument. So now you multiply it by 1, that's the derivative of x, plus, because it's negative of the negative, so plus sine of x. And there you have this. We arrive at the same answer. Let's do number 7. All right. So do you see how I told you that you have to memorize the derivatives of trig functions? Well, that way it'll be easier for you to do this. So let's see. What is number 7? Okay. So y is the tangent of u. Now what is u? U happens to be 10x minus 5. So dy by dx would be the derivative of y with respect to u multiplied by du by dx. Alright, so what is that? What is the derivative of tangent with respect to u? Secant squared u. What does this represent? This represents this part. Okay? Now, multiplied by the derivative of u with respect to x, okay, which is just 10. So, rewriting everything now in terms of x and putting the constant in the front, you get 10 times secant squared of what is u? 10x minus 5. So that's the Leibniz notation. Now let's apply the direct method where you use the composition to begin at the beginning. So it's the tangent of 10x minus 5. So what is the derivative? What is y prime with respect to x? Well, you look at the big picture. The outside function is the tangent. So what's the derivative of tangent? Secant squared of its argument. Okay, so just copy that same argument. But then you multiply by the derivative of the argument of tangent, which is the derivative of 10x minus 5 is 10. And that tells us that we get the same answer. 10 times secant squared of 10x minus 5. You see how you get the same answer. Right, let's see. Number 8. You see how what we're doing here is really practicing, because the more you do chain rule, the easier it is to find the pattern. So y is the negative secant of u. And then what is u? U is a polynomial x squared plus 7x. So now dy by dx is the derivative of y with respect to u multiplied by the derivative of u with respect to x. So let's go ahead and write that down. What is the derivative of negative secant of u with respect to u? It's negative secant u tangent u multiplied by the derivative of u with respect to x. It's 2x plus 7. And then the rest is just rewriting, applying now the composition. So we get minus secant of what? X squared plus 7x times tangent of x squared plus 7x multiplied by 2x plus 7. Now it doesn't matter how you write this. It's understood that these are all multiplied to each other. So you have 3 factors: secant, tangent, and this binomial. Right, so again, we will apply the other method where we do the composition in the beginning. So what is it? Y is the negative of secant of what? What is now u? It's x squared plus 7x. So what is y prime? We take the whole picture. The big picture is the negative secant of something. What is the derivative of secant? The derivative of secant of something is secant times the argument, secant of the argument, tangent times tangent. So we take minus secant times tangent of that same argument multiplied by the derivative of the argument. So let's write that. Okay. So far what it is we took the derivative of the outside, which is secant, the derivative of secant, multiplied by the argument, the derivative of the argument of secant. So that's 2x plus 7. And there you have it. You arrive at the same answer. So keep practicing. And then let's continue with some more exercises. Right here, this is really the composition is already applied, and you're asked to find dy by dx, or here dy by dt. So in number 41, so this is now this is no longer using the Leibniz notation. It's the second type of using the chain rule, is that we want to find dy by dt, and it's already expressed in terms of t. Okay, I have used coloring, that way you can see what we're doing. So really, when you have sine squared of pi t minus 2, it's really the sine of pi t minus 2 has been squared. So the outside picture, the outside function is a squared function, squared of a function. So take its derivative, so that means it's 2 times that, okay, multiplied by the derivative of sine. So that's cosine of what? Pi t minus 2. Multiply, we don't stop, we keep going because there's 3 embeddings here. In other words, you have u, or you have the outside is a squared, then it's acting on a sine. Now sine is acting on pi t minus 2. So far we took the derivative of the outside, multiplied by the derivative of the next inside, multiplied by the derivative of whatever's inside here, which is now pi. It's pi minus 0, which is just pi. So what do I write here? Whatever was squared to begin with, so that's sine of pi t minus 2. I hope you're getting the hang of it now. So let's rewrite everything so that we can see how it looks like. It's 2 pi, I'm just putting all the constant coefficients in the front, times sine of pi t minus 2, multiplied by the cosine of pi t minus 2. Alright, so let's see. Suppose we want to do number 43. Let's try number 43. And you've got y is 1 plus cosine of 2t to the negative 4. Okay? So what is y prime, or dy by dt? Well, look at this. You are taking something that was raised to the negative 4. So the outer function is like u to the negative 4. And what is u? Whatever has been raised to the negative 4. So apply power rule on the big picture. So minus 4 times whatever was raised to the negative 4. Now minus 4 minus 1 is minus 5. And this is now what is it's now 1 plus cosine of 2t. Okay, but we don't stop there, because so far we just took the derivative of the outside. Now we take the derivative of whatever was raised to the negative 4, and that's equal to 0 minus, so it's minus sine of 2t. And then we don't stop there, because sine has another function. It's not acting on just t but 2t, so we multiply by the derivative of the argument. So it's 2. Where did the 2 come from? It's the derivative of this one. So here, this is its derivative. It's that. Take its derivative. 2 came from the derivative of 2t. Alright, so keep practicing. It's how you do number 44 as well. How about this one? Okay, these are even more complicated functions. So what is this? Is we apply chain rule and use all the other differentiation rules. So let's say we want to do number 45. Okay, so number 45, the big picture is that y is t times tangent of t that was raised to the 10th power. So as you can see, what we've got is the outside is again the power rule. But then the inside is a derivative of, we're going to take the derivative of the inside. It turns out that it's a product of t times the tangent of t. So that means we have to use product rule when we take the derivative of the inside. So on the outside, y prime would be what? Y prime would be 10 times something raised to the 9th multiplied by the derivative of whatever sits here. So just copy t times tangent of t. Multiplied by what? Here we're going to have to take its derivative, right? So what's the derivative? Using product rule. Okay, so what happens here? Well, I'm going to write what's the derivative of t, which is 1, times tangent of t, plus t times the derivative of tangent, which is secant squared t. Okay, so that becomes, alright, so the rest is just really simplifying. Okay, so we've got, if we look at this, it's just 10 times t tangent t raised to the 9th multiplied by tangent of t plus t times secant squared t. There we have it. There might be other ways to simplify, but I think that that would be a final answer. Alright, suppose we want to do, say, number 48. How do we do number 48? In number 48, the outside is a power rule. As you can see, it's something that raises to the negative 5. And then, how do you take the derivative of the inside with respect to t? Then we have to use quotient rule. So let's do that. So y is something that was raised to the negative 5. So that's 3t minus 4 divided by 5t plus 2. Right? So let's see. What is y prime? That means what is dy by dt? Well, take the big picture. What is the big picture? We take negative 5 times something raised to the negative what? Minus 5 minus 1 is minus 6. But you just copy the argument 3t minus 4 divided by 5t plus 2. Then you don't stop there because that's just taking the derivative using the power rule with respect to the argument of y, which is really, this is like your u. The whole quotient is your u. So multiply by du by dt, and that is where we're going to have to use low d high less high d low over the square of the low we go. So what is the derivative of a quotient? I would take the square of the bottom right away. 5t plus 2 squared. Okay, and then low d high means, let's copy what's at the bottom, 5t plus 2 multiplied by the derivative on the top, low d high, so what's the derivative of the high? It's 3, less high d low, so 3t minus 4 times the derivative of the low, which is 5. Alright, so as you can see, we've got a lot of things going on here. So let's go ahead and just write this as negative 5 times 3t minus 4 over 5t plus 2 whole thing raised to the negative 6. And then let's see what's going to simplify at the bottom. This becomes 5t plus 2 squared. And then this is going to be what? 15. Right? It's 15t plus 6 minus 15t. Right? And then that's negative times negative plus 20. So really that means, do we get to cancel something? Yes, this is now cancelled. And then you have 6 plus 20 is 26. So you've got negative 5 times negative 26. So what is 5 times 26? Or rather, 26 times 5 is 130, right? Because 125 is... Okay, so let's go ahead and write this down, therefore, as Right, so this becomes negative 130 multiplied by, how about we rewrite this now as 5t plus 2 over 3t minus 4 to the 6, because when you take a fraction that's raised to a negative exponent, you just flip the top and bottom. Multiplied by, remember I put the 26 in the front, so this is just 1 over 5t plus 2 whole thing squared. And look at what's the final answer. Well, this now is, there's an exponent of 2 here and there's 6 here, so you have a negative 130 times 5t plus 2 raised to what? 4th power divided by 3t minus 4 raised to the 6. So this is really involved. Much of the rest of it is making sure you know your algebra. Okay, so what is that? What did we do? We took the derivative of the outside using power rule, multiplied by the derivative of the inside using product division rule or quotient rule, and then the rest is just simplifying until we arrive at this for an answer.